All right, so here we have an example out of chapter 5.2. I believe it was 5.2.2 homework, number 29. So this was a problem where guessing, and just from kind of talking to the classes, I'm guessing that everyone kind of looked at this left side and saw that it looked a bit bigger, and mistook that for it being more complicated than the right here. Now there's a couple things here. One, what I mean by that is that even though there's more terms here, we have 1, 2, 3, 4, 5, 6, 7, 8 separate trig functions as opposed to the 4 or 5 that we have over here. What we're looking at over here is that even though that's the case, over here I have all these tangents, and I know that I can switch tangents into sine and cosine. So for me, I'm pretty sure that going to the right side is going to be the best route. Now, if you're really stuck on going on the left side, I'm not going to do it that way, but one of the things I would notice is that if we look at the numerator here, and it's always a good problem-solving strategy to just take a look at a piece of the problem. And if we just look at the numerator here, and I'm going to write this right up here, but we look at the left side, the first term of the left side, because I'm noticing here that both numerators of the left and right have two terms. This one has sine x cosine y plus cosine x sine y, so it has those two, and this one has tangent x and tangent y. Now if we just look at the first terms here, sine x cosine y, and one strategy we can try is to go ahead and just try to make this one piece look like it. Because whatever we do to this piece, sine x cosine y, we're going to have to do to the second piece of the numerator here as well, because of the distributive property, since we'll most likely be multiplying. And that's the same thing that's true for here. So if I want to make this look the same as that, well, what I really want is I want a cosine right down here, right? Well, if I do that, then what I'm really going to end up with, okay, is I want a cosine. So I would want to multiply this by 1 over cosine x, because if I do that, then I'm going to have sine x over cosine x. And then I also want to get rid of this cosine y, so I can do that if I multiply by cosine y. Okay? Now, what you're going to wind up with, if in this case, is that we're going to want to do this to the top and bottom, and then we can kind of look at what would happen to the other term here, in which case the cosine x's would cancel out, and we'd end up with sine y over cosine y, which would get us to our tangent y. That's the strategy if you want to work on the left. I'm going to go and work on the right since that's the easier route. So the first step here is we should look at it and say, okay, well, I actually have the right number of terms. If you look at it, like I said before, you're adding two things on the top of both numerators, and we're subtracting two things on the bottom of both denominators. So I'm thinking that in the end, if we manipulate this, we should actually be able to get to this fairly easily. But I have all these tangents. I'm going to go ahead and change those. I'm going to change the tangents into cosines. Okay? So I'm going to take this first tangent right here, okay, and I'm going to rewrite it as sine x over cosine x. Okay, and then with that, and I'm going to put a little bit of space here, and you'll see why in a second. Plus, okay, the second piece here, tangent y. Oh shoot, not supposed to be tangent. Sorry, that's going to be sine y over cosine y. Okay. And then we do the same thing to the bottom. Okay. So again, the one here, I'm going to go ahead and leave that as just 1 over 1. And again, you'll see in a second why I want to leave that as 1 over 1. Plus, and I'm going to give myself a little bit of space, plus this piece right here, well, that's going to be tangent, or sorry, I'm doing it again, cosine, again, sine x over cosine x. Okay, that's this piece right here. And then the second one is just times, okay, and we can actually just leave it as one fraction. Tangent would be sine y over cosine y. That's that second piece right there. So hopefully your brain's spinning a little bit and you're realizing why I wanted to leave this extra space here. Okay. Well, there's a couple reasons why I might want to do that, but if you notice here, there's a couple things. One, I have these two fractions here. I have fractions on the top, fractions on the bottom. And, you know, I could go ahead and actually do this division already, and I'd probably get there, but I think that it's going to help me out if I go ahead and I multiply, or I'm sorry, I get these with a common denominator, and that way I can go ahead and just add them up and just deal with a fraction over a fraction. So with this one, I have cosine x here. Well, I want a common denominator between cosine x and cosine y. So I know a trick that I can just multiply each one of the denominators times each other on the top and then on the bottom as well. Sorry, so cosine y and cosine y on the top. And then over here, we're going to do times cosine x over cosine x. Okay. And then on the bottom, well, this one's 1, which always makes things a little bit nice in that it's pretty easy. I'm just going to multiply top and bottom of this by cosine x cosine y. Okay. And if I kind of do all of that math or all of that stuff there, I'm going to wind up with sine x cosine y. Okay. Plus, well, I have a common denominator now, so I can just add plus sine y cosine x. Which is looking pretty nice, actually. I'm pretty much already there. And then on the bottom, well, the 1 isn't really going to be important because I'm just multiplying by 1. I get cosine x. Okay. Oh, and I'm sorry, all of that was over cosine x cosine y. Okay, and so I just worked on this top piece. Now I'm going to go ahead and draw another big fraction here, and I'm going to work on the bottom. So on the bottom, I just get cosine x cosine y, and since I have a common denominator now, I can just add the numerator plus sine x, or I'm sorry, sine y. Wait, oh, sorry, I'm not looking at it right. Sine x, yeah. Sine x sine y, and that's going to be over cosine x cosine y. So hopefully you're noticing that I actually already have what I was looking for. My numerator is the numerator up here, the numerator of the numerator, okay? And then my denominator, the numerator of my denominator here is actually the denominator that I want to end up with. And then if I look at both my denominators, well, they're probably going to end up canceling, and they in fact are. Okay. Now I can rewrite this as a division problem, okay, or actually really is I can multiply by the reciprocal. So if I wanted to do this, I'm going to go ahead and rewrite it over here, give myself a little more room. What we're going to wind up with is what we have on top, sine x cosine y plus sine y cosine x all over cosine x cosine y times, I'm going to multiply it by the reciprocal of this, so I'm just going to flip it, times cosine x cosine y. Again, we know that from fraction, from our fraction rules, is dividing by this is the same thing as multiplying by the reciprocal, over cosine x cosine y plus sine x sine y. Okay. And if you notice here, I can always cross cancel. I'm going to cancel out this piece and this piece, and that just leaves me with what I have on my numerator here. Okay, so that's equal to sine x cosine y plus sine y cosine x all over my denominator cosine x cosine y plus sine x sine y. Okay. And if we look back to our original problem, you can see that they are identical. So we have proven that this identity is verifiable or true. And that's it.